So in this video we are going to look at the environment of PSpice and Orcad Capture. Actually in this one we are going to look at the environment of Orcad Capture. Now Orcad Capture and PSpice. Basically PSpice is part of Orcad Capture. PSpice is the simulation or simulation software, and Orcad Capture is where you are going to design your circuit. So once you design your circuit, you design your project where you have your circuit, and then you create the simulation, and once you run the simulation, then PSpice is going to run. It is going to open the PSpice window and it will show you your simulation results. So basically here I'm going to introduce Orcad Capture, and you have to click on the Orcad Capture light version. If you don't have the full version, the one that I put on canvas is light version, and you can also download the light version from Cadence website. So make sure do not start PSpice. Do not click on the PSpice. Click on the Orcad Capture, and that's where you're going to create your circuit. So let me introduce the Orcad Capture environment. On the left hand side you have the toolbar where you can select different tools to create a circuit. Three tools you will be using actually only out of all these, which is the place part, and right now all of them are grayed out because you have not created a project yet. Once you will create a project, then you will see that these buttons are going to be enabled. Right now they are disabled. But in any case, you're going to be using three buttons over here. You're going to be using place part, you're going to be using place wire, and you will be using place ground. And all of these place parts, place ground, and place wire are also present under place in the menu. Place wire, place part, and place ground. So ground is right here, part, component, wire is right here. So all of these you can also get from their part is right here, but it's easier to just click on these buttons. Okay, on top you have the menu, file menu, design, edit, and all those things, and then you have the new document, open document, and save, and all those things. And then under that you have the simulation settings, editing, simulation profile settings, simulation editing. You have the probes with which you are going to measure your voltage, current, power, and so on and so forth. You have the meters, voltage meter, current meter, watt meter. So these are basically for your simulations, and you don't really need to use right now these things because in this course the simulations that we are dealing with, it's not required for you to use FFT or anything. Okay, so this is the main screen. When you will run your Orcad Capture, this screen is going to open up. Right now it's blank. There is no recent files because I don't have any files that I have simulated yet. Once you start simulation, creating your file, then you will see the files are going to start populating over here from your previous simulations. So what do you do? How do you create a circuit for simulation? So you create a circuit using new project. So either you can click on the new project from here, or you can go to the file and then new and project. So when you do the new create project, the default, let me show you the default. Default is going to look like this. Schematic, the first time you're going to run, that is. Schematic is going to be enabled out of these four choices, and location is going to be blank at that time. You have to choose where you have to save your project. So right now I have say I'm gonna save the project in my software application folder. You can choose any folder, but initially you will have a schematic enabled out of these four choices. Now schematic, if you leave it and then you give a name of your project, and when you're giving name of your project, make sure you don't start with the number, start with a letter, and do not use spaces or special characters in the name. I'm pretty sure underscore is perfectly fine to be used. I would say don't use any special character. For example, project 1, that's a good name, or homework 1, right? That's a good name, project 1. So I can also use project underscore one, and that's perfectly fine. But do not use project space one. So I'm just gonna call it project one. If you're working on your homework, you can call it homework one HW1 or something. But the most important thing is do not leave it at a schematic, because if you do leave it at a schematic option, then you can only create the circuit, but you will not be able to simulate it. To create and simulate the circuit, make sure to choose PSpice analog or mixed AD, this option. And once you choose this option, then you will be able to create a circuit and you will be able to simulate the circuit as well. For some reason, if you forget about it and you left it as schematic, what you're gonna see once you create your circuit, you save your circuit, you will see that these buttons where my mouse is, the simulation buttons, they are all grayed out. So you will not be able to do any simulation, and then you will realize, oh, I chose schematic instead of PSpice AD. So what you have to do, you don't have to worry about anything. You don't have to create a new project and a new circuit. All you have to do is you copy your circuit that you created. You still open a new project. You open a new project, you copy the circuit, and then in the new project, you choose PSpice analog or mixed AD. Open, once you click it, then it's going to open the schematic editor. Let me click it. It's gonna ask you, create PSpice project based on an existing project or blank project. Choose blank project, and then it's going to open the schematic editor. And let's say, as I was telling you, if you do initially chose schematic instead of PSpice AD, just copy your circuit, open a new project, and then once your page opens up, then you can paste your project, and copy is simply as simple as you basically select the whole circuit, either using your mouse, as I will show you, or just do Control A, and then Control C is going to copy it, or right click, you can do copy, and then bring it here, your mouse, and then Control V is going to paste the circuit, or right click, paste. So you will not have to recreate the whole circuit. If it's a big circuit and you made a mistake, you chose a schematic, don't worry about it. Copy paste in a new project, and then make sure you make that project to be the first option, PSpice AD. Alright, so observe now, all of these buttons are enabled now. All of the toolbar buttons are enabled now. Simulation button, the first one is enabled. Probes are enabled, so on and so forth, right? So many buttons are enabled now. So you are ready to create a circuit. How do you create a circuit? So in this toolbar menu, you need, as I said, you will be using three things. You will be using place part, click it, and observe. I have already placed some parts, so I'm gonna delete those. So once you run it for the first time, it's gonna look like this. It's gonna look like this, blank. Here you're going to add different libraries where you keep different components for the electric circuit. Now the most commonly used libraries are analog library and source library. Analog library is where you will find your resistors, your capacitors, your inductors, and some other components, but most of the time you're going to be using these three components from analog library: resistors, capacitors, and inductor. And perhaps you will be using analog library in every circuit that you're going to create, so remember that. And the second library is the source library that you will be using to place different types of sources: sinusoidal source, AC source, DC source, square wave, whatever you wanna use. So how to add a library? Go to the Add Library button where my mouse is, click on it. This screen is gonna open up. The library that you are adding has an extension OLB. So make sure you're adding OLB. There is another library, LIB. With this, only the OLB library folder is going to open up. Now, these are all the libraries that come with the free version of PSpice. Remember, free version has its limitations, as you can see in the tutorial. You can create a circuit up to a certain number of nodes. That is, certain number of components can be in a circuit, and if you exceed that number of components, you will not be able to simulate the circuit. You can still create the circuit, but after a certain number of nodes, the circuit simulation is not allowed with the free version. But for this course, of course, you can use free version because circuits are not that big. So all these libraries, actually they didn't used to come with the free version before light version. They included in the free version, all of these used to come with the full version before, but now they come with the light version as well, which is extremely beneficial for students. So as I said, let's grab the analog library. So go to the analog, double click, and it's gonna open over here. Likewise, go ahead and add source library. Go to the source, double click, and source is gonna open up over here. Okay. So as you can see, source has, these are the components or parts, right? They have a bunch of parts. Current sources, current start with I. Current sources, voltage sources start with V, and so on and so forth. And likewise, analog component, when you click, you will see capacitor, electrolyte capacitor, variable capacitor, and resistor, 45-degree resistor. So different components in that list as well. So how you create a circuit? You go ahead and I'm going to create a simple circuit. Let's say we grab resistors. So double click on the resistor. It's going to stick with your mouse. And then put as many resistors as required by your circuit. Put them. It's going to be stuck to your mouse as long as you don't release the resistor. And observe that every time you put the resistor, the name of the resistor, it becomes R1 to R2 to R3. So for a new instance of resistor, the name changes as well. I'm going to go ahead and zoom in so it's easier to see right here. Okay. Now let's go ahead, and you can do a lot of things with each component in PSpice or Orcad. You can do a lot of things with the right click. If you select a component, right click, and you can see you can mirror the component, rotate the component, edit the properties of the component, and a bunch of things, delete, copy, and all those. I'm going to go ahead and rotate this 90 degrees right here. And likewise, I'm going to rotate this 90 degrees. And I can just leave it as it is right here. Okay. Now observe, if you double click on any of the name, you can change the name of the component. Once again, remember, do not use spaces when you are choosing the name of any component. You can use underscore, but don't use the spaces, and the first character should be a letter. When you're choosing the value of a component, again double click and change the value. Now K stands for kilo, so this is a 1 kilo ohm resistor. It does not show you the units ohm. It does show you can use the units of capacitors, inductor, and voltage. V capacitor, C F, sorry, capacitor for farad, F, and inductor for Henry. But for ohm, of course, the unit is omega, the shape is omega, and it does not support that character. So 1K simply represent 1 kilo ohm. You can change the value of that. Let's say I want this resistor to be 100 ohm. I want this resistor, leave it at 1 kilo ohm. I want this resistor to be 500. I want this to be, let's say, 2 kilo ohm, 2K. And then let's assume this resistor to be 900 ohm. So you can change the values of resistor, you can change the name of the component, and everything. It's very simple. The next thing is I need a power supply for the circuit. So let's go ahead, choose source, and I'm just gonna use a DC power supply, VDC, right? So I'm gonna put a DC power supply. But by the way, when you have to release any component which is stuck to your mouse, just press escape or right click your mouse and release component. Now let's say that this power supply is 9 volts, so I'm using a 9 volt battery. Let's see, right? You can change the value by double clicking it, and observe that you have the volt V over here. Now one thing is extremely important. Anytime you are putting the value and the variable for that value or prefix, let's say it's microvolt or kilovolt, make sure do not leave any space between the value and the prefix or the variable. If you leave a space, you won't be able to run your simulation. It's going to give you an error. So the value and the variable that represents its unit, they should not have any space between them. Okay, so I have a bunch of components. Now what I have to do, I have to connect them. So grab the wire right from here, place wire, or go to the place menu, and wire is right here, place wire. So grab the wire, oops, and click on any node of one component, left click, and then go to the next component, left click. It's gonna connect. Right? Left click, left click, click, click. Now you can also reroute the wire whatever you want. For example, if I want to reroute like this, I click here, go down, click here, and click here. So I can rewire as well. I'm just gonna clean it up. I don't like this. There you go. You can select it and delete it. Alright, so I connected all the wires. Once again, if you click on any wire or stuff and right click, you have many options. Edit wire properties. You can change the color of the wire. You can change the width of the line. Let's say I'll make it, you can change the style of that. Right, so I can make it thick, I can make it thin, whatever you want, right? Go back, just leave it actually, it doesn't matter. Okay, so the circuit is complete except one thing, that every circuit needs to have a ground, which is the reference voltage. All the voltages in your circuit is measured with respect to ground. Where is the ground? Ground is right here. Place ground, or you can go to the place menu item and ground. So go ahead, choose that. Make sure choose 0/caption, and the name should be 0. Okay. Put it here. Ground should be connected. Well, generally, it is connected to the negative side of the power supply, but you can connect it anywhere. I'm going to connect it here. So this whole node is going to be grounded. So the value of the voltage over here everywhere is 0, and all the voltages in the circuit will be measured with respect to the ground. I'm going to go ahead and clean this wire up. I don't like this. Go to the wire properties and choose the regular wire. Okay. So this is my circuit. Make sure you keep saving it. So Control S or press the save button, and it is going to be saved in let me go and save it again. This is basically where you see your project, your design and stuff. I'm just gonna press a save here again, because observe that there is a asterisk over here. That means it's not saved, design is not saved. So I'm gonna press a save over here, and then this project is gonna be saved. It's gonna be saved in the folder that you chose. Now let me go to that folder and show you how many things it's going to save. Observe, project 1 folder, where the simulations are going to be saved once you run the simulation. Project 1 data source name file, project 1 DSN link file, project 1 OPJ file, project 1 DBK file. So one project created 4 files and one folder where simulations are going to be saved. Now when you are opening your project, once you close it, when you open your project, make sure you click on the OPJ file, project 1, which is the OPJ file, okay, to open the closed project. When you have multiple circuits, let's say you're doing a homework and you have like 3 different circuits that you want to simulate. If you go to the project1.dsn, DSN stands for design, then you can see schematic. Schematic has a page, and this page is this basically. Now you can add more pages under the same schematic. So I can add a new page, page number 2, under the same schematic, and when I click it, it's gonna open it, right? And you can create another circuit over here. The only drawback of doing this is that once you run your simulation, It's going to go through each and every page under the schematic, and if there is an error anywhere, it's going to generate error and it's not going to run the simulation for any of the pages. If it finds duplicate names or values, I believe that it will also generate an error. So the best way to do it, to do multiple circuits, for example, if I give you a homework, it has 5 circuits, 5 exercises, then instead of putting new pages under schematic, put new schematics and one page under each schematic. So let's say when you click on design, you can add a schematic 2, and then you can add a page in the schematic, right? So now once you save it, now if you open this, this is where you can create your new circuit, and then you can execute each schematic separately. So the other schematic is not going to be bothered by, for example, schematic 1 is not going to be bothered by schematic 2. So if there is an error in schematic 1, then it will be fine because it's not running. Your schematic 2 is running only. But whichever schematic you want to execute, you want to simulate, make sure it is on the top of the list. And how do you make it go on the top of the list? Right click and make root. So that's going to go on top of the list. Right now I have schematic 1 which has a circuit, so I'm just going to keep it as the root schematic, and then we can create a circuit, another circuit in schematic 2, and then I will show you how to save your files and how to submit your homework, and the simulations that you have to do for the first homework. We will start with those simulations in our next video.